Good morning, and thank you for joining us today. My name is Erin, and I'm an education specialist here at the Solid Waste Authority of Palm Beach County. Today we're going to be taking you behind the scenes to look at what happens after your garbage has burned. What happens to all of that ash? One of our engineers, Kyle, is going to take you into Renewable Energy Facility 2 and answer those very questions. Now, if you've joined us in the past, then you might already know that Palm Beach County generates about 17 million pounds of solid waste every single day. So the Solid Waste Authority of Palm Beach County is tasked with managing all of that waste. And if you're trying to imagine that, it's about 27 feet high inside of an entire football field. So a football field piled 27 feet high with garbage. That's almost to the top of the goalposts, because the goalposts are about 30 feet tall. So imagine that much solid waste every single day. So we manage all of that through our integrated waste management system. And throughout our various programs, we've explained different parts of how we do that. So today's focus is going to be on that ash after that burning process. So let me hand it over to Kyle, and let's go ahead and take a look at that.
Hi everybody, Kyle here again. Today we're going to talk about the other byproduct of combusting waste. We talked about all of our environmental equipment and the emissions side of things, but the other remaining factor is the ash. So as I said in some previous videos, the main purpose of a facility like this is to reduce the volume of garbage. So we can reduce the volume of garbage by over 90% by combusting it. And that allows us to make the landfill last 10 times longer than it normally would, which is great. But we still need to deal with that ash. So there's two types of ash. There's bottom ash, which is all of the heavier material, the non-combustible stuff like steel, concrete, or any of the heavier ash material. But there's also fly ash, which is very fine and gets pulled in the flue gas, which gives smoke the color, so to speak, of what you see like if you were to do a campfire. That would be fly ash making the smoke. So we have two types of material. We got bottom ash and fly ash that we need to deal with, and we're going to go into the equipment we use to make sure that that stuff is properly and safely managed. All right, so here we are back at the boiler, and you can see we've got our fire going here. It's good, strong, good combustion. And as we get to the end of our travel, you can see the burnout. So this is the bottom ash, and you can see there's some non-combustible material. There's some steel in there that we can see, some concrete, rock maybe. And then the rest of this material is just the combusted remaining ash. So as this boiler continues to move in our bright cycle, this material will fall off the edge and eventually fall down into our discharger. So this is the beginning of the bottom ash, the start of its travel through our ash management system. All right, so now we're down at the discharger level. So if we were to look up through this hole, we would see the fire that we were just looking at. And this is where the bottom ash falls in. And if we look down in the bottom, we can see a water level. And inside this discharger, we have this water level, which will quench any of the fire. It also cools any of the hot ash. And then under this water, there is a hydraulic ram, which constantly pushes this ash forward and up a ramp on the other side of the wall onto the left side here. And slowly that ash will be pushed up so that it has time to drain and dry, and eventually will make its way onto a vibrating pan and then onto the rest of our ash system. All right, so here's the viewport that we were just looking in, where we can see the ash fall into the discharger. If we take a step back and we look, we can see this chute here, which is filled with water, and eventually a ram at the bottom, which pushes it up this slope, and then it ends up going down onto a vibrating conveyor. And if we see here, this is a conveyor, and it's called a vibrating conveyor. We can see those springs down there, right? And these springs here, and we have a motor which creates an action so that the ramp actually throws the material forward like this, moving it a little bit each time it rocks back and forth. And eventually, it takes that across our whole building, all three boilers join up, and makes its way to our ash building. All right, so we're on the transition from our boiler building into our ash management building. And if we look down there, we can see the end of the vibrating conveyor, and we can see that material getting rocked off onto our incline belt. So the next step in our ash transfer system here is an incline belt, which is a rubber belt which goes up on an incline. And we can have a good look here at what the leftover ash from our process looks like. Again, everything that is combustible is combusted, and what's left over is rock, brick, concrete, or any steel, the non-combustible material. So as you can see, there's a big, drastic reduction in the volume of waste, which is one of the largest redeeming factors of this process. All right, so we're in our ash management building now, and this is the top end of our incline belt. So this material falls off our belt after being transferred over here, and then it goes down onto a finger scalper. So if we look down here, we see that material falling down. Then it goes onto a set of finger screens. Anything that's under 6 inches falls through, and everything larger eventually makes its way out. Sliding off those screens down here into a pile of material that's meant to be sorted. At which time we use a mag frame, which has an electromagnet, to sort all of the steel out, and we make a pile of the steel, which we then send off to recyclers to be made into new material. Again, taking things that people don't want and turning them into things that people need. Okay, so we've been talking about bottom ash, which is the heavy ash. But there's a second type of ash that's generated, which is called fly ash. And we call it fly ash because it's actually picked up in the flue gas stream and brought through the whole boiler. So as we're pulling that flue gas through the boiler to absorb the heat, the fly ash is being pulled with it. So we have multiple places where we collect that ash. In the past, we've talked about our environmental equipment. So here's our SDA, and at the bottom of our SDA is a hopper. So as we change direction with that current of flue gas, some of the ash falls out. So in this hopper, it's collected and added into this drag chain conveyor. And if we follow that drag chain conveyor, we can see all of these chutes. And these chutes come from our fabric filter, whereas the last step where we collect all of the remaining fly ash that's in there gets trapped in those bags. And then when an automated clean cycle happens, that ash is dropped down into the chute, combined with all of the other fly ash, and eventually into joining conveyors and makes its way to our ash management building. All right, so if we continue to follow our bottom ash after we went through the finger scalper, what's left here is anything that should be under 6 inches in size. And what we do to make sure that we're recovering as much material as possible is we send it through another magnet. So if we look at this material here as it comes through, we can watch it get picked up. Anything that's magnetic, right, anything that has ferrous metal in it, is going to get pulled up onto that magnet, and if we follow it along, we can see eventually dropping that off, and then it getting conveyed out to a separate location for recovery, while the remainder of the non-ferrous material, so any remaining ash, transfers on in a separate direction. All right, after the magnet, we've pulled all of the ferrous material out. The remainder of that bottom ash falls down on these set of screens. If you look closely here, you can see small openings in the screen. That knocks off any of the small ash, and what we have left over is any of the small to medium-sized material. And what we're trying to do here is sort that in hopes of recovering as much non-ferrous metal as possible. Non-ferrous metal being copper, aluminum, and even gold. So as that material comes through, it ends up getting put onto an eddy current separator. So here we have a belt conveyor which moves the material at a pretty quick speed, which puts a certain amount of momentum into that material. And then here at the end, this roller, if we can see here all the way at the end, has an eddy current magnet. And the way eddy current magnets work is if it's a non-ferrous material, it actually repels it. So the opposite of how the ferrous magnet works, this will actually kick the non-ferrous material away. So by having a certain amount of momentum, at the end, anything that's non-ferrous gets an extra boost, which should push it farther. And here we have a separating screen, with the idea being that non-ferrous material gets a little kick, and you can see some of these things get popped off a little bit farther than the others. The ones that go farther are the non-ferrous stuff. And then we can take that to be recycled and turned into new products, right? All right, so continuing the path of fly ash, we now go into something called repugnant. So fly ash is very, very fine, very lightweight, and easily transferred and blown around. So what we do is we put it inside here, we mix it with some water, and we get it to a certain moisture content to keep it from being blown around. Then last, we mix the fly ash with the bottom ash to make combined ash, which goes to the landfill. All right, lastly, here we go. We've got to look at our different storage areas. So we can see out here is our recovered large ferrous metal. Here's our stockpile of combined ash, which will be making its way to the landfill. And if we go on this side, we can look at some non-ferrous. All right, and then here is our bunker filled with non-ferrous metals that will be sent to recycling facilities to be turned into new products. And lastly, we have some more ferrous metal that comes off of that small drum magnet that we looked at as well.
Thank you so much, Kyle. If you have any other questions for us, please type them in the comments and we'd be happy to answer those. And if you come up with something later or something else you want to know about, please feel free to email us at education@swa.org. Also, you can go to our website, swa.org/education, to see all of the exciting programming we have for you at 11 a.m. weekdays. Thank you for joining us today, and I hope to see you again next week.